Yes, children, actually the earth gets warmer as we dig deeper, and many times things just come out from under the earth like a hot spring that you may have heard of, especially if you are from Alaska or parts of Japan and so on. And that's geothermal energy. If it's hotter down, then you can use the difference between the temperatures to extract energy, to cool things, to heat things, and so on and so forth. Talking about Japan and the hot springs, here are some nice macaques. You can see that they have a lot of furry skin, which means they are living in cold temperatures, and they are sitting in the hot spring as it's hot, very cold outside. They're soaking in the warmth of the natural hot springs, which keeps bringing up energy from under the ground, heating the water with sulfur, and supposed to be healthy for you. So you can find some very nice images of these monkeys. Of course, we are talking about geothermal energy, and we are looking at Earth's structure here. We have living on the land crust here, and the ocean has an ocean crust, and if you go down deeper, you have all kinds of layers down into the inner core, which is, got two layers, inner core and, two inner core and outer inner core. And there is a lot of energy from the beginning that is constantly being produced, which is producing pressure and temperature and magma that can come out once in a while as volcanoes. But looky here, you have all these houses, and this house is basically sending cold water down using the hotter temperatures in the ground, which we call geothermal energy. Thermal is always related to temperature, geo is related to earth. Geothermal energy, and it sends back warm water, and voila, you have a nice heating system for the house. Have you heard of Japanese macaques? They are those woolly monkeys with pink faces that sit in steam baths. They don't just do it for fun, but because they live in an area where there is a thick layer of snow in the winter, and the temperatures can easily get down to minus 20 degrees Celsius. That is bone-chilling cold. Without me, geothermal energy, no monkey could stick it out. Okay, the water in these lakes is so warm because there are lots of volcanoes in the area. Not every volcano explodes. There are some volcanoes which quietly put the heat out. The deeper you go into the earth, the warmer it is. But in volcanic areas like Japan, I'm just under the surface. Some of the heat I give off is from the time of the earth, from the time the earth was born, long time ago. As I said, all that energy is at the center. The rest comes from the radioactive decay, atoms naturally changing into different sorts of atoms and radiating heat when they split up into different things. If you don't know what that is, don't worry about it. When you get to a chemistry class and the teacher starts saying isotopes, atoms, and so on, you jump up and say, ha ha, I've heard this before. Please explain properly and tell me about energy. Nuclear reactions of that kind are natural processes that have been going on right under your feet for billions of years. My heat is, of course, ideal as sustainable energy. There's plenty of it, and no CO2 is released in doing that. Okay, also I don't care about the weather in countries like Japan and Iceland. I'm so close to the feet underground that I drive entire power stations. There are geothermal power stations, which means they produce enough energy for entire neighborhoods and towns. Okay, normally you need a fuel to make the steam that generates energy, like we did with burning coal or the steam engine and the train was running on coal and so on. But in those countries, I send steam straight out of the ground. People put a turbine on top and I make the turbine turn. What if there is no steam coming out of the ground? Then just pump some water past me in the ground like this to make it into steam. But You can use me in other ways too. In Iceland, they pump warm water under the sidewalks so that they're always free of ice. Iceland is called Iceland because it freezes a lot, and the sidewalks can be frozen, but you can use this water just below the sidewalk, and boom, you can walk around, run around without slipping and falling and so on and so forth. Okay, so well, where was I? They are always free of ice, sidewalks, and they send hot water to the houses for the shower and for heating. No extra energy, just energy from the earth is doing all this. That's probably not going to happen in most places, but hey, you are doing your best. In lots of countries, I am deeper down. So you have to drill deeper, and that costs money, of course. So deep drilling is only worthwhile for bigger companies. In Netherlands, for example, vegetable growers have created a heat network that goes down to a couple of kilometers, 2 kilometers into the ground. Water runs through the pipes, which I heat up to 85 degrees centigrade, almost boiling water. The growers can use the warm water to heat their greenhouses in a sustainable way and grow things happily in the greenhouse without worrying about the weather outside. That's nothing in comparison to Iceland or Japan, of course, but there is always a catch. What is the catch? We'll right, we talked about the cost of drilling deep down when you don't have geothermal energy close to the surface. The tectonically active places, what does that mean? That these continents are moving islands, like Iceland and Japan. Australia is moving and India is moving. So India, on the other hand, doesn't have much geothermal energy, but Japan does, and Iceland does, and many parts in Alaska do as well, and so does Hawaii. Okay, so Hawaii is fairly warm, so you have to use geothermal in other ways to heat the water and so on, or convert it into steam and then drive a power station. But in Japan and Iceland, where it can get so cold, even the macaques have figured out how to use it. They are living on renewable energy, folks. Right? That's fantastic. So we'll come back and talk about the next source, the nuclear energy. This is a bit more complicated, but it is part of the renewable energy portfolio. What is a portfolio? Let's say you are worrying about energy, then you have energy coming from, say, fossil fuels, from renewable energy, but within renewable energy you may have solar, wind, geothermal, water and so on, and in fossil fuels you may have coal and oil and gas and diesel and so on, or you may have bioenergy as well. So your range of energy sources can be considered a portfolio of your energy. So we have to track the portfolio of energy and use biomass where it's convenient and possible. Use geothermal energy, use water energy, solar energy, wind energy, and batteries and storage along with all those things. So we'll come back to nuclear energy. Okay.